Welcome to the next part of our discussion involving aldehydes and ketones. In our first discussion, we went through identification of aldehydes and ketones and the nomenclature, how to name them. In this part of the discussion, we're going to be talking about synthesis. So, how do you make an aldehyde or a ketone? Well, aside from them both being carbonyl compounds, the other thing that aldehydes and ketones have in common is that they are both derived from alcohols. So you could say that both aldehydes and ketones result from alcohol oxidation. Now, if you have a primary alcohol, oxidation will lead you to form an aldehyde. So, for example, if I start with methanol and I oxidize it, I'll come away with methanal. Secondary alcohols are typically oxidized to form ketones. So if I have isopropanol and I oxidize it, I will come away with propanone or acetone. Now, what about tertiary alcohols? What happens when you try to oxidize, for example, T-butanol? Well, oxidation of T-butanol basically gives you nothing. There is no reaction. Why is that? Well, we probably need to look at the word oxidation. What exactly does oxidation mean? At least within the context of organic chemistry. Now, when you had general chemistry, you were told that oxidation was the increase in oxidation number of an atom resulting from the loss of electrons. Well, that's really nice, but that doesn't exactly explain for us how an alcohol can go to an aldehyde or ketone. So we probably need to add to that explanation of oxidation. So think of oxidation as the addition of oxygen, the loss of hydrogen, which is referred to as dehydrogenation. And if you have to take biochemistry after this course, you'll hear a lot more of, of that particular term. Oxidation can also be the formation of multiple bonds. So let me go back. So if you look at methanol and compare it to methanal, you should notice a couple of things. While there's no real addition of oxygen, you do have multiple bonds forming and you do lose hydrogen. Look at T-butanol. If you focus on the carbon that bears the hydroxyl, last time I checked, carbon could only have 4 bonds. So forming a double bond isn't likely. Also, if you Again, look at the carbon that bears the hydroxyl. That carbon is tertiary, meaning it's bound to three other carbons. There's no hydrogen for you to lose. So, in case anybody's ever wondered, why can't you oxidize a tertiary carbon? This is why. Or let me rephrase that. Why you cannot oxidize a tertiary alcohol. Sorry about that. Okay. Now, I do have one word of warning though, and this is common mistake. You have to be careful oxidizing primary alcohols because aldehydes are not the only potential product. If you look here, I have ethanol. Now, true, oxidation of ethanol can produce ethanol, but look here. Oxidation of ethanol can also yield this thing. This is a carboxylic acid. This is acetic acid. So what's the catch? Why do I get an aldehyde in one case but a carboxylic acid in the other? Could it be the type of oxidizing agent being used? And the answer is absolutely. Typically, if you have a primary alcohol and you use a strong oxidizing agent, for example, permanganates, chromates, dichromates, you're going to get an acid. You're going to go straight to carboxylic acid. But what if you want just a simple aldehyde? Well, I guess the obvious answer is don't use a strong oxidizing agent. Instead, you might want to use an oxidizing agent that we may call middle of the road, meaning strong enough to oxidize the alcohol to an aldehyde, but not so strong as to oxidize it straight to carboxylic acid. There are two agents that are usually recommended in a situation like this. One is pyridinium chlorochromate, or PCC for short, and the other is called pyridinium dichromate, or PDC. So, yeah, this is all really, really nice, but what about the secondary alcohols? We did say that secondary alcohols can be oxidized to form a carbonyl, i.e. a ketone. Well, does the oxidizing agent matter in the case of secondary alcohols? And the answer is not really. Secondary alcohols can be oxidized to form ketones using either PCC or PDC, but they can also be treated with a strong oxidizing agent, such as a chromate or a permanganate. The idea is that in the case of a secondary alcohol, oxidation will give the ketone, period. So what other methods do we have for making an aldehyde or a ketone? Getting ready to take you back away to our early conversation involving reactions with benzene, and particularly how to make an alkyl benzene. And if you recall, we discussed something called Friedel-Crafts acylation. Now, we also talked about Friedel-Crafts alkylation, but, well, let me just show you, just so you can see the obvious difference. Remember, right now we're talking about how to make an aldehyde or a ketone. Now, with Friedel-Crafts acylation, if you recall, we started out with this. This was called an acyl halide. The actual name for this compound is called acetyl chloride. Let me write that down for you. Acetyl chloride. Now, if you notice, the acyl group does have a carbonyl carbon. We'll come back to that in a second. So, the acyl halide forms a transition complex with aluminum chloride. The aluminum chloride is the catalyst. If you recall, for electrophilic aromatic substitution or reactions with benzene, we had two major catalysts. One was a ferric type halide, ferric chloride, ferric bromide, and the other was aluminum chloride. You notice that the acyl halide adds on to the aluminum chloride as a whole. The lone pair of electrons on the oxygen are going to help rearrange. So we get internal rearrangement at the carbonyl carbon, thereby forcing a break between the carbonyl carbon and this chlorine. And I come away with this. This is our electrophile. This is what's going to actually add onto the benzene ring. And when it does, you notice that we form a carbocation within the ring. The ring is also partially broken, in case you didn't notice. And in order to reform the ring, we're going to use the tetrachloroaluminum anion, that's going to be our Lewis base, to get rid of this proton, form the ring back again, and there you go. Now, this is a ketone. It is an aromatic ketone. Now, when we discussed Friedel-Crafts acylation a couple of months ago, we wanted to reduce this carbonyl to a methylene and thereby make an alkyl benzene. That's if you want to make an alkyl benzene. But again, we're talking about aldehydes and ketones. So we could stop right here. And this is called acetophenone, or if you use the alkyl naming method, methylphenyl ketone. Now, are there any other ways to make an aldehyde or ketone? There are some lesser referred to, and just for the sake of completion, I will mention this. Please feel free to read up further on this if you so choose. But ozonolysis of alkenes is a cleavage process whereby imagine breaking this alkene right in half and making two ketones. That's exactly what you're doing. Um, this method isn't used very often. It's more used as an analytical tool more so than an actual mode of synthesis. And the last method that we're going to discuss is hydration. Hydration of an alkyne. Now, when we've talked about hydration in the past, we always talked about hydration of alkenes to yield an alcohol. Well, as you can see, hydration of an alkyne will actually yield a carbonyl compound. Typically ketones, but there are examples of aldehydes being formed as well. But the majority of the time, it will be a ketone. All right. Well, that's pretty much all I have to say about synthesis of aldehydes and ketones. Please join me in the next video within this discussion where we'll discuss and talk about what you can do with an aldehyde or a ketone once you've made it. So we're going to talk a little bit about reactions. All right, thank you for your attention, and we'll talk soon.